Hello everyone, let us look at DLS based aggregation analysis of biologics and biosimilars. Protein aggregation characterization is a key to successful biopharmaceutical development, as protein aggregates can be formed at any stage of the manufacturing process. DLS, or dynamic light scattering, also known as photon correlation spectroscopy or quasi-elastic light scattering, is a well-known technique for the determination of hydrodynamic size and the state of aggregation in proteins. It is based on a very simple principle of light scattering. The sample is illuminated by a laser beam of light, and the fluctuations in the scattered light are detected by a fast photon detector at a fixed angle theta. DLS finds application in measurement of size, charge, molecular weight, protein-protein interactions. The prior knowledge required before DLS measurement is the viscosity of liquid. The sample preparation is simple, as it only involves mere filtration of the sample using 0.22 micron filters. The software used for the analysis of the size, charge and other parameters is in compliance with the regulatory standards. The instrument which is used for the determination of these parameters is from Malvern Panalytical Zeta Sizer Nano ZSP. Let us begin with the experimental part of DLS analysis. The first step is sample preparation. It is a very crucial step, as the presence of dust particles or small particles may interfere with the DLS measurement. So it is very important that the sample is filtered using 0.22 micron PEX filters of Axiva. So first we will take the sample using a 5 ml syringe. Then fit the PES filter at the mouth of the syringe and filter it through the filter into the cuvette. After you have added the sample to the cuvette, wipe it from all sides. Then open the sample compartment and place the cuvette inside it. Let us begin with the sample size measurement. In order to begin with the measurement, open the Zeta Sizer software. To begin with the measurement, open the measurement file. Then go to the Measure tab of the software to start with the measurement. Under the Measure tab, you have options for different types of measurement. Here we are going to measure the size of the sample, so select size and enter appropriate name for the sample. Then go to the sample dispersant, which is formulation buffer in our case for the rituximab sample. Then select an appropriate temperature for the measurement, which is 25 degrees Celsius, and equilibration time to 60 seconds. Select an appropriate cuvette, which is polystyrene disposable cuvette in our case. Under the measurement tab, select the appropriate measurement angle, which is 173 degree in our case. Set the number of measurements to 3 so that we can take an average of the 3 measurements. Then press on OK and start with the measurement. Particles greater than 1 micrometer sediment over a period of time and cause a number of fluctuations in the beam. Particles absorbing in the red region should be avoided since the laser operates at 633 nanometers. Most of the buffers are compatible with DLS. The viscosity of the buffer can be calculated using the DLS software, as it is required to be entered during the measurement. The ionic strength should be greater than 10 millimolar to reduce the debye layer drag. After the measurement is done, we get results in the form of different types of measurements such as intensity based distribution, volume based distribution, and the correlogram. In the intensity based distribution, we see that the Z average size of the sample is 16.5 nanometer with a polydispersity index of 0.218. We also see that there is a high sized population which indicates the presence of aggregates. The percentage composition of the aggregates is 1.2%, whereas 98.8% of the population is of the monomer. The intensity weighted distribution shows how well differently sized particles are detected from a fit to the autocorrelation function of the measured scattering. The intensity based result can therefore be highly sensitive to a very small number of aggregates or dust, as scattering intensity is proportional to the sixth power of the particle radius. In short, one or two individual large particles may scatter more light than many small particles. The number and volume distribution shows the relative proportion of number of differently sized particles and volume occupied by differently sized particles. DLS measurement also gives correlogram of the sample. It is a qualitative assessment of the sample. The nature of the correlogram will tell us whether the sample is monodisperse and whether its size is large or small. Steeper the line, monodisperse sample it is, and quicker the decay, smaller sample it is.